Hi, I'm Greg Alvarado, Chief Editor of the Inspectioneering Journal, and welcome to another Whiteboard Discussion. Today's topic is going to be Design Stage RBI. It's a practice I've seen done quite a few times, and it can be very handy if you know what you're doing. So let me go over a few things and hopefully it'll be helpful for you. Number one, we know that in capital projects, one of the things that corrosion materials engineers often get blamed for is gold plating equipment, because the capital projects engineers don't want to spend any money or as little as possible. So if we say, hey, make it out of 6 chrome or make it out of some austenitic stainless or some other material, they start belly aching and say, oh, we're spending too much money. So a good way to keep everybody honest and to justify things is to use RBI to take a look at the material of construction and what the reliability will be expected to be if we use that material of construction. So that means we're going to have to define things or identify things like damage mechanisms, expected damage rates, and time to first repair, how often you're going to have to inspect it, how much each inspection is going to cost in order to keep that level of reliability for that equipment that you desire. So it may be something like a prime piece of equipment, a critical piece of equipment, or it could be a unit or some subsystem of that, however you define that to be. So when we use RBI, then we can be very objective about it and go into it eyes wide open, understanding what risks we're accepting or what risks we're going to avoid. Another good thing about design stage RBI is you get a head start on your inspection program and your inspection strategies. So if it is a critical piece of equipment, you can actually look at, okay, do we need to do a baseline inspection in the shop or shortly after it's been installed, for instance, for heavy wall pieces of equipment, and we're going to inspect in particular areas so that over the years as you go back and perform things like UT inspections, if you find something, you know whether or not it was an original fabrication flaw or something that's occurred after it's gone into service. The other thing, if you're doing a unit or part of a unit, you can begin to consider things like piping and other pieces of equipment, although at the design stage, you're not going to have a lot of details about piping, but at least you begin to be able to anticipate what you're going to run into. Another thing about design stage RBI that people often fret about or worry about is, gee whiz, we don't have all of the information. How are we going to handle the inventory amounts for consequence modeling inside of the equipment? Just rationalize something that makes sense to you. You're going to know after you get that equipment into place and become part of the overall formal RBI program that that equipment may not have had an accurate inventory amount in there as it's installed into the whole unit. So adjust it and assign it to the right inventory group after it's in. But the value is in identifying if it's worth it to make it out of the piece of equipment that's going to give you, or excuse me, out of a material that's going to give you more reliability. Another example I want to mention before I close this whiteboard discussion is how it can be used for certain critical pieces of equipment. I remember many years ago when a customer was installing a flue gas scrubber, because the original flue gas scrubber was made out of 304 stainless. Well, there were chlorides going through that stack, and over a few short years, it cracked badly and actually fell in half, and part of the flue gas scrubber stack fell over on the maintenance shack, and thankfully no one was injured. But now they were looking at 3 different options to replace that flue gas scrubber. One was a Hastelloy C-line carbon steel stack. Another one was a fiberglass reinforced plastic stack, an FRP stack. And another one was a lined carbon steel stack. So we were able, from a RBI, traditional RBI standpoint, to project what those future costs and reliability would be going into the future. But because FRP and a line stack were so susceptible to temperature, we had to take a look at the reliability of the control system to make sure that the temperature stayed below a certain level so they wouldn't destroy the stack or destroy the liner in those cases. So there we had to do another study of the reliability of the instrumentation and control system. But then we were able to put them together and put together a 15-year looking forward maintenance strategy and cost picture for what it would cost to have the level of reliability that they wanted to achieve. Also, you'll find that doing what-if analysis come in real handy here. So make sure when you do this, you're able to do that pretty easily. And that's about it for this one, for this whiteboard discussion. Thanks a lot for joining me. And if you have any questions or any comments, please enter them in the area below. Thank you and have a great day.